Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my lovely viewers, we're going to finish off our little adventure with quadratics and cubics and inequalities and solving them and all that lovely jazz we're going to learn set notation, which is just another way of writing down your answers to your inequalities, pretty much. It's a thing you might get asked in your exam, and it can trip up a lot of people if you don't know how to do it right. Don't worry, it's pretty easy. We'll get into it. Let's go. Okay, so to start off, we're just going to learn what a set is. So in maths, a set is just a collection of objects. For example, you might have the set of all regular-sided shapes. That would be like a triangle, a square, a pentagon, and so forth. But in this video, we're going to be concerned with the sets of numbers in general. And this is how you write them, and I'll give you an example. For example, you have the set of 1, 2, 3. Now, couple important things to note here. These curly brackets tell you this is a set of things, okay? And here we have the elements of the set, 1, 2, and 3. So this is the set of the numbers 1, 2, and 3. It's not too challenging, am I right? But what if we want to write down something more general and something that will help us write down the answers to the solutions of our cubic inequalities and so forth? Like, for example, what if we want to represent all the numbers greater than 7, for example? And this is how you do it. So you start with, you open your set, beautiful, so you're saying this is a set, and then you write down x. Now in this position, x just means a number, just means any general number, like it does in normal maths, just another variable. And then we write down this semicolon here, and this semicolon means such that. How you read it is such that. So far we've got the set of numbers such that. Okay, this is great. Now all we need to do is write down x greater than 7, and then we close off our set. Okay, so how we can translate this word by word. We can read from left to right, and I'll show you how. So start off, the set of numbers such that the numbers are greater than 7. Okay, brilliant. So we found a way to write down the idea of numbers greater than 7. And it's pretty much that easy. Now there's only one little harder thing we need to get into, and I'll meet you on the next board for that. Okay, so the one last detail that we need to cover is what if, for example, you have to do this in solving quadratics a lot, solving quadratic inequalities. What if you want to represent the idea of numbers that are greater than 7 and less than -3, for example? So how are we going to do that? And how we do that is using something called the union symbol. And it looks like this. It's a big old U. And how you can read it is and. Basically, it translates to and. For example, the set of 1, 2, and the set of 3 is the same as our lovely set 1, 2, 3. Now that's pretty cool, and by extension we can use this exactly the same way we used it here to represent the idea of numbers being greater than 7 or less than -3. Some of you might already be able to guess how I'm going to do this. It's really not that hard. Let's see how. If I just rub this out. Right, so first of all, we're going to write down one of our conditions. The numbers need to be greater than 7, so that's the first thing we're going to write down. We're going to write down the set of numbers such that the numbers are greater than 7. And then we're going to write down our big, I don't really have enough space to fit it, so I'm just going to put U. So we've got set of numbers such that the numbers are greater than 7, and open another set, the set of numbers such that numbers are less than -3. So boom, that's how you combine two closed off sets like that. You just use the union operator. And that's pretty much all there is to it. So that's great. Let's get into some examples, shall we? Okay, my boys, this first one here goes like this. The graph of the function y equals square root of x minus 2 is positive for all x greater than 2. And the question we're going to solve square root of x minus 2 is greater than or equal to 0, and we're going to try and solve this in set notation. So the question tells us that the function always outputs positive numbers when x is greater than 2, which means that to solve square root of x minus 2 is greater than or equal to 0, we just need to write down the solution that x has to be greater or equal to 2. So how do we do that in set notation? Easy as discussed. We open our set. We say the set of numbers such that, and we need to convey the idea of numbers being greater than or equal to 2, so we say x greater than or equal to 2. Boom. It's really that easy, isn't it? It's great. I love it. Right, on to the next example. Okay, so my boys, this next one we're going to do is just a little bit harder, but it's pretty much the same thing. We've got the graph of y equals x squared plus 2x minus 3. Lovely little quadratic, if I may so say myself. And the question is solve x squared plus 2x minus 3 is greater than 0. And we're going to want to do this in set notation just for the practice. Right, so first of all, let's solve the inequality. Well, if you've watched my previous videos, you'll know that the answer is x has to be greater than 3 or x must be less than negative 1. So we're going to have to use set notation to convey the idea of numbers being greater than 3 or numbers being less than negative 1. So how are we going to do this? Well, first we'll open our set and let's do greater than 3 first. We'll say the number of numbers such that numbers are greater than 3. Okay, great. So we've conveyed that set of solutions, but now how are we going to also include these ones? With the union symbol. And we're going to say, and, I'm going to move these pens down, and the set of numbers such that the numbers are less than 1. Boom. It's that easy. We've just done it. It's really that simple. We just convey the idea that numbers are greater than 3 or less than negative 1 using set notation and crucially using the union operator. That's brilliant. And let's go to the hardest example. Okay, so my boys, this last one is probably the hardest example you use and probably the most useful since solving cubic inequalities could come up quite a lot in your exam. So here we go, we've got the graph of y equals x cubed plus 5x squared minus 4x minus 20. And we're asked to solve that graph is less than 0. Okay, so first let's identify our solution. So less than 0, well, okay. Values less than negative 5, they're going to be outputting numbers less than 0, so they're going to solve our inequality. And also numbers in this little region, I'll just rub that out, in this little region between negative 2 and 2 are also going to solve our inequality. So using set notation, we're going to need to convey the idea of numbers being less than negative 5 and numbers that are between negative 2 and 2. So let's do that first. First of all, let's start with the easier one. We're going to say, okay, open the set of numbers such that the numbers are less than minus 5. Boom, that's our first set of solutions. And then we're going to have to include another set of solutions. So we're going to need to use the union, so and the set of numbers such that. Okay, now let's think for a second. How are we going to represent the idea of numbers that are between 2 and negative 2? Well, we're going to have to say negative 2 less than x less than 2. Sorry, greater than x or less than 2. So boom, there you go. We've solved our cubic inequality and we've written down the answer in set notation. Now, if you ask me, that's not too difficult, but it can just catch a lot of people out who haven't revised it because it does sneak up on you, I'll tell you that. Anyway, that'll be the end of this video, guys. Just a quick little one about set notation. I hope you enjoyed it. We've completely finished our cubic and quadratic journey, and we've just got a little steps more until we finish chapter 2, and then we can get on to geometry. It'll be fantastic. But in all, thanks for watching, my boys. I'll see you in the next one. Bye-bye.